Power steering repairs go way beyond a quick part swap. There are many factors that weigh on the success of a power steering repair. As a result, much of that success falls on doing the complete job in conjunction with replacing the hoses every time. In this training, we will demonstrate that in order to assist with the complete job, offering the coverage necessary to nearly guarantee the hoses will be available for the vehicle being repaired is important. We will also demonstrate how the quality of the hoses available makes a big difference in the quality of the repair. The hoses available have many features that assist both with the repair and with the ongoing life of the hose. After we establish an understanding of hose quality and features, the importance of doing a complete power steering repair will make more sense as we dive into how the condition of the hose can affect the entire power steering system. And last, but certainly not least, is a quick look at a simple preventative maintenance measure that can be taken either during an install or at any time during the life of the car using a power steering fluid filter. No one offers more coverage than power steering hoses than we do. We offer coverage for both pressure lines and return lines for over 200 million vehicles in operation today. With 2,300 SKUs covering domestic applications, this amounts to 99% of coverage of domestic makes and models currently in use. For Asian manufacturers, we offer 93% coverage through 1,300 SKUs. And the 400 SKUs we offer for the European makes and models accounts for about 64% of the vehicles in operation in North America. When it comes to hose features, our hoses start with an identical match to the OE hose in form, fitment, and function. Any feature that the original hose had, our aftermarket replacement hose will have either an identical or an improved version of that feature. Most importantly, we match the exact fittings and path of the original hose following from the OEM. Exceptions to this only exist when the original path cannot be duplicated as a result of the original manufacturing process of the vehicle. As for consolidation of the hoses in our inventory, we follow a strict policy adhering to our commitment to OEM form, fit, and function. We will not eliminate or consolidate a hose with another unless it again matches fittings and path through the engine compartment. Additionally, our hoses are made with what is called a double bead lock crimp. This is superior to the competition in eliminating the possibility for leakage at the fitting by locking the fitting in place between two beads when it is crimped to the hose. To make mounting the new hose easier for the technician, many of our hoses have adjustable mounting brackets that allow for flexibility when placing the new hose. The rubber hose materials that we will be discussing shortly are also resistant to oil, heat, and ozone that are among the most common reasons for failure, ensuring a long life of the replacement hose. And finally, heat and abrasion shields are used in areas that are prone to contact with hot engine components or open to road debris to prevent failure from these destructive elements. Beyond the features of the hose, the material of the hose itself plays an important part in the overall quality. The market recently has gone through a transition from a hose material known as CM rubber to an improved quality CSM rubber. But before we discuss some performance specifications of these materials, it is first important to understand some terminology. In identifying the quality of a hose material, the standard tests for the market rely on a metric known as impulse cycles. When we use the term cycle, the best visual understanding of what that means is if you were sitting in a stationary car and turning the wheel all the way to a lock position in one direction, this is considered the equivalent of one cycle. Cold cycle tests are completed at negative 20 degrees Fahrenheit, negative 29 degrees Celsius, and hot cycle testing is done at 300 degrees Fahrenheit, 149 degrees Celsius. SAE standards for hoses only rely on the hot testing cycle to determine passability of the hose. Our thought is, in colder climates, before the hose and fluid in the hose has had a chance to warm up, the strain on the hose from a cold cycle is just as critical. Now that being said, the number of cycles necessary for cold cycles is significantly less, as the inside of an engine compartment is much closer to the 300 degrees than to the negative 20 degrees during the majority of time that the car is in use. Okay, so now that we have an understanding of what a cycle amounts to, here are the two types of hose materials consistent with the aftermarket today. CSM hoses have been tested with cold cycle counts over 5,000. This is a marked improvement for the CM hose material that this replaced that was only tested to 2,400 cold cycles. So already there is an improvement to the cold weather durability of power steering hoses in the aftermarket. Now, HNBR hose material, which is similar to what is used by some OEs, has been tested up to 20,000 cold cycles before the tests were halted and no failure had occurred. That amounts to a 400% durability improvement over the industry standard CSM hose material. And taking that quality statement one step further, the SAE standard for hot cycles a power steering hose must pass amounts to 220,000. The HMBR material hoses were tested beyond 1 million hot impulses without failure. Again, a more than 400% gain in the durability of the hose. Therefore, over time, a change to HNBR hose material may be considered a wise choice for vehicles operating where cold temperatures are possible, not just in cases of -20 and below. Now, applying what we just learned about the material differences in the hoses and some of the features preventing failures, what does a failure look like and what causes it? Unfortunately, failures don't have a uniform appearance or performance change in many cases. This is just the nature of how the hoses themselves fail over time. What happens is, over time, a combination of different factors typically cause the failure to occur from the inside out. As the hoses move through different temperature cycles from hot to cold repeatedly over the lifespan of the hose material itself can become brittle and hard. This causes the hose to become much more rigid and less tolerant of the internal impulses caused by the operation of the system. Slowly but surely, cracks begin to form and fluid begins to leak out, causing a slow decline in performance and eventually failure of the system if the fluid level gets too low. It is unlikely that a hose would ever have a large catastrophic failure from this type of depreciation, as the hoses are rarely under enough pressure to cause such a failure to occur. Another likely culprit of hose failure is even more menacing to the entire power steering system. Over time, small particulates make their way into the hydraulic system. These particulates could be debris from outside of the system, small shavings of metal from the hard part, or even pieces of rubber from the inner lining of the hose itself. As these particulates make their way around the system, the tiny impulses produced by the pump can cause these particulates to rub up against the inside of the hose and nick away at the rubber material and cause two problems along the way. The first problem is caused by the eventual wearing away of the inner lining of the hose, causing loss of fluid in cases where damage can become severe enough. The second is the slow buildup of this debris over time in the recesses of the hard part, which could lead to failure of any of those components if a blockage were to occur. Therefore, because of the complexity and systemic nature of power steering failure modes, it is important to do a complete repair every time. A complete repair starts with a complete flush of the power steering system. Before adding any replacement parts, flush the entire system with clean fluid that meets or exceeds specs for the vehicle. This will remove all the debris that was the likely cause of the failure before it can become a problem for the new install. Consider replacing all hard parts involved, as the seals and other sensitive internal components of the hard part in the system are likely compromised by the same method that caused the failure that initiated the repair. And of course, if replacing a hard part, be sure to use new hoses. For the same reasons that it is a good idea to replace all the hard parts involved, the hoses have likely been damaged over the course of use and are likely due for replacement, or are likely a cause of the debris that caused the hard part failure, and will likely lead to premature hard part failure if not replaced as well. And last but surely not least, when doing a complete power steering repair, be sure to add a filter to the return line to prevent future failures caused by debris. A filter on the return line to the pump removes any particulates from the system before a damaging run through the pressurized side of the system. Removing these particulates keeps the inner lining of hoses safe from producing more debris that will inevitably lead to another hard part failure in the future. A filter also has the added bonus of preventing warranty returns, as it increases the likelihood of removing system debris that could still be lingering in the system after repair. In general, a filter will extend the life of a new power steering system repair or keep the existing power steering system working well into the future. So now you can see that a complete understanding of power steering helps lead to a complete repair job. Make sure that the right hose material is being used for the prolonged life of the vehicle. Understand how and why the power steering system failed in the first place. Do a complete repair job by flushing the old fluid, replacing the hard parts and hoses, and add the all-important filter to help prevent future failures and premature or warranty returns. Thank you for your time.